Hello everyone, welcome back to another discrete time linear systems problem, and today we are going to be solving for problem set 5.1. So for the first question, our goal is to find the Fourier transform x of e to the j omega for the signal x of n 1/5 to the n u of n. This one is going to be very simple. All we have to do is recognize that we have a Fourier transformation. So just like our Fourier transformation says, when we have the input signal x of n is equal to a, which is just a simple coefficient, a to the n u of n, we can find the Fourier transform by just taking the a value, which is our 1 to the 5th, and putting it down below. So it then is going to come out to 1 over 1 minus 8 e to the minus j omega, which then comes out to 1 over 1 minus 1/5 e to the minus j omega. So that's just how that is. It's just a simple transformation, and where we have to be able to recognize our a value. Now for the second one, our goal is to find the inverse Fourier transform of y of n. So I was able to break it down into 3 simple steps. So first, we need to set the equation with our limits. When we look back at the graph, we can see that the y of e to the j omega is 0 when omega is greater than 2 pi over 3, and 0 when omega is less than negative 2 pi over 3. So we can set our limits to only focus on this region when the region is 1, between minus 2 pi over 3 to 2 pi over 3. So now we have our equation. Y of n is equal to 1 over 2 pi with our limit, and then y to the e to the j omega multiplied by e to the j omega. Then we set our limits to the equation and just solve as below. And once we get down here, we then are going to be able to recognize again, being able to recognize that this is a Euler's identity, which is really the sign of the Euler's identity. So when we do simplify it, we have 1 over 2 pi j to the n multiplied by 2j sine 2 pi to the 3n. And then all we gotta do is just simplify even more. So the imaginary part cancels out, as well as the 2, and then all we're gonna have left is y of n is sine 2 pi over 3n over pi over n, and it's just simple as that. Thank you. Come again.